Hello and namaskar again. So we are back again with another episode. As you know, every day we come with one episode of Career Corner where we focus on one career at a time with one guru of that area, an expert of that domain who speaks about that domain in depth. This is for those who are contemplating coming into that domain or who are already there studying that particular subject to understand the nuances, the in-depth knowledge of that area. Today we have with us Professor Dr. Saikat Chatterjee. Dr. Saikat is the head of the Department of Mechanical Engineering in the School of Engineering and Technology, Adamas University, Kolkata. Mechanical, a traditional field, one of the oldest field, if I can tell, civil and next to that mechanical, would be the most well-known domains of engineering across the world. To such an extent that people would be asking for innovations or differences or newer evolutions in the area of mechanical, and we'll know about that. But before we go into 21st century mechanical engineering, let's understand the evolution of the field. Welcome to the show, Professor Chatterjee, and it's our pleasure to have you here today. You, at a very young age, you are the head of the department and you are a guru of that area. It would be great if you could talk to youngsters who are thinking of mechanical engineering as a career or who are already into that, studying. If you could tell to them how the field of mechanical evolved over time, since times immemorial, or if I can say, since the industrial revolution in the world. Right. If you can tell that.
Okay. Thank you very much for that welcome note, and you have rightly said the ball rolling. Right, let us talking about mechanical engineering. It is generally said it is the oldest and the broadest of the disciplines, right from the era of, you can say, Mesopotamia, Egypt or Persia, which is currently known as Iran and Iraq. So the basic, the evolution of the mankind started, if we can say, wheel is the symbolic fact, wheel and axle systems, or let us say levers. And many of you may be surprised that cranes were also utilized by Mesopotamians. Right. So, in that way, mechanical engineering is right from the beginning, I mean from the before Christ times, and then came the industrial revolution followed by mechanization, and mechanization led to industry controls. So, today we talk about analog controls, we talk about digital controls. So, at that time, that is after industrial revolution, during the mechanization, there were mechanical devices which is to control the manufacturing and other process systems. So, I should say that the foundation was laid by the American Society of Mechanical Engineers right in 1880, which is just after civil and mining. So, that was the third embodiment of engineering that came into a solid foundation that we call mechanical engineering, and since then its canvas has been enriched by various additions right from mechanization to automation, and today in the fourth industrial revolution we look at industrial internet of things, which has a lot to do in the mechanical engineering field. So it's a very sweep curve, it's a very rich follow up that has happened right from the prehistoric times to the medieval to the modern and the futuristic ahead.
Very good. You have traveled almost 3 centuries in 3 minutes. Thank you very much for that. If you could very categorically, with specific features of each, talk about the 5 generations of industrial revolution. So, industrial revolution 1.0, which started with wheel, as you said, 2.0, 3.0, 4.0, which is now going on,
right,
and 5.0, which is expected. So, if you could talk about these 5 generations or evolutions of industries and industrial revolution over the history of mankind, if you could talk about it.
Right.
And how is each distinct from the other?
Right. So, if we see the industrial progress, actually there were different milestones at different times, and that brought the classification as we go for, let us say, 1.0 to the upcoming ahead, that is 5.0. Now, if we talk about industry 1.0, that is about industrial revolution that revolutionized the entire, the society, the culture, the lifestyle of people. And in industry 1.0, there were the foundations of mass production that was introduced. And but they were all mainly your manual controls, the hand controls, the hand operated things, like let us say a person creating say certain object with his hands, let us say a potter creating a pot, earthen pot using his hands. Next came the mechanization process. In the mechanization process, we went for the mother of all machines that we call machine tools, and then machine tools came into picture, the mass production and the batch production were improvised, and thereafter in industry 3.0 came the control, the mechanical control. At that time the mechanical control was done, let us say, by the using of cams, by hand wheels, by levers, and once it was also said at that time that a mechanical engineer will like to say that give me a lever, I will change the course of the earth. So that was the kind of impact that it had during the industry 2.0. And thereafter in industry 3.0, what came is automatic control. Right. So slowly the sequential control, the programmable logic control, they came into being. And in industry 4.0, what we see is the modified versions of PLC, the DCS, that is the distributed control systems, are slowly being merged into the PLC. The PLC has improved, that is the programmable logic control has improved to such an extent that it has merged with DCS, and the introduction of Internet of Things in the industry, which we specifically call IIoT or Industrial Internet of Things, which is a subset of the IoT. In fact, IoT generally deals with the consumer usage, but the industrial IoT deals with the industry processes like manufacturing, supply chain management, as well as energy management. Right. So with that, now we are looking ahead to industry 5.0.
So the computing was introduced in industry 3.0.
Right.
It evolved into IoT in 4.0,
right,
with the power of the internet getting to the next level.
Right.
And with 5.0, yes.
Yeah. So if we ask the industry that what is ahead in 5.0, the main thing what they cite as that we need to stabilize first of all the IoT applications as industry 4.0. So what we see in 5.0 is only the stabilized version of the IoT, right, but still with the hope that there are new graduating engineers with the creative and innovative minds are going to contribute and come out with new approaches of using digital technology, and this digital technology has got no bounds. So that is what is to be explored in the industry 5.0.
We'll talk about that even furthermore. It's interesting to know for youngsters who are coming into the field of mechanical engineering, they need to understand how industries have evolved and the role of the mechanical engineer and his art and craft and science has evolved over time. I do consider that there is a creativity in every science and scientific application as well. So while it is undoubtedly the scientific principles, practices and mechanical outcomes or machine outcomes that you use, there is also the impact or role of creativity, art and culture as well, because all those things, the soft aspects of civilization influences the hard aspects of civilization as well as you go ahead. Interestingly, industries started from Europe.
Right.
Today, I mean Europe, if I can say 1.0 and 2.0 was Europe dominated. Mm-hmm. Then with 3.0 and today 4.0, industries has gone beyond Europe. Right. So from a geography or region point of view, how has mechanical engineering evolved from starting from England till mm-hmm. today, if you could still speak
right.
about that.
So as you can see that the industrial revolution was majorly started in Europe. So the progression has started from there. Then the mechanical engineering and the industry as a whole slowly percolated into the other parts of the continent, and then the American civilization took up, and with their rich capital investment they went ahead. Then Russia was once upon a time a very strong power, but during the Cold War it suffered certain economic breakdown, and now slowly what is happening, it is shifting to the oriental parts of the continent. So what has happened now, China has emerged as a key player.
Right.
Right. So now China has got a major advantage. It can produce the same product at a price of 10 rupees to a price of 10 lakhs. So it's a varied range. And what they have done, they have utilized or they have optimized the manpower, the infrastructure, the technology, and all these symbiosis has created a broader range. And moreover, their marketing policy, their economical strategic outplays as a whole has placed country at one of the major point. Now, if we look in that way, if we look towards the oriental part, now India is not laying behind. So, with Prime Minister Narendra Modi's ambitious project called Make in India, now with the Confederation of Industry and Indian Industries playing a major role, with the National Design Policy in place, with the Indian Design Council formed, so we are all in the process of creating a design enabled industry. Now, this will be having a long term effects along with the short term process that is going through. So, what is going to happen is now the industry is opening up during the globalization, and though there has been a setback but due to COVID-19 situation, but this thing is only temporary.
Great.
So, right, so that's the way.
Region wise we find industrial revolution and thereby mechanical engineering as an area, as a function which exacerbates or which supports industrial revolution, evolving from UK, the British land, and then becoming a pan-European character, and today Germany perhaps leads
in the materials and
metallurgy and many aspects of mechanical engineering, and thereby it has moved to the rest of the world, starting with US, and now the oriental side of industrial revolution and mechanical engineering. If you look at Asia as a whole, China, yes, is the leader, and there is reasonable growth of industrial revolution and mechanical engineering in Japan and South Korea, if I am not wrong. And in Africa, the evolving countries have been South Africa, which almost over the last half a century has evolved, and in the last 20 years, Kenya and Nigeria are opening up in a big way, evolving in a big way. And as you have rightly said, India is looking forward to large manufacturing driven functioning of the economy ahead, particularly in the times when the government is wanting to be self-reliant and make in India as a process. Very well said. That's how the regional growth has happened, and we have spoken earlier how Industrial Revolution 1 to the 5 expected ahead have also evolved. With this background in mind, we move on to understanding of mechanical engineering deeper. So there are various forms of engineering. First of all, I would like to ask you, sciences, natural sciences, engineering and technology, how are they different?
Right. So, I should, instead of giving the bookish definitions of differentiating science, engineering and technology. So, what I will say that let us say we have a knowledge base, what we call science, and what an engineer will try to do, he will try to attach a wheel to that knowledge base.
Right.
Keep it rolling. So, that is engineering, and the knowledge put on the wheels reaches the right destination and creates the transcendental changes. So, that is what I call technology.
So, the knowledge from which the application evolves, that fundamental knowledge is natural science, and the application of it is engineering, and the product of it is a technology. That what comes through the application of that particular knowledge, you rightly said, applying will to that knowledge and taking, in fact, knowledge is complete when it is applied. So, applied natural sciences is engineering.
So, I will like to add also that what is science today is technology tomorrow.
Technology is a product. So, it has to go through the engineering process to evolve into a technology. Great. That's a great beginning of the discussion. And within this field of engineering, the broad domain of engineering, there are various forms of engineering. Civil is the oldest, mechanical then, electrical then, electronics and communications next, production engineering, instrumentation engineering, nanotechnology, and various other forms of biotechnology and food technology, and various other forms of technology or engineering that we see today. How is mechanical distinctively different from the other forms of engineering?
So, if somebody asks me that how do you look at mechanical engineering, so I will just say that mechanical engineering focuses on 3 things basically: interest, industry and infinite possibilities.
Very good.
And these 3 things rely on the 4 pillars which we have been learning throughout civilizations in mechanical engineering and has been revamping. So, they are what we call design, analyze, manufacture and maintain. So, these are the 4 pillars on which we can build up the interest, the industry and the infinite possibilities. Now, mechanical engineering has got the other focal points, like it is a larger canvas. So, mechanical engineering, you talk about any applications, talk about manufacturing plant, talk about aircrafts, talk about watercrafts, talk about a high speed train, talk about a metro rail, even you talk about processing of a chocolate bar to breathing life into an artificial heart. So, you find mechanical engineering everywhere. In a nutshell, I should say it encompasses art and entertainment to medical to space. So, that is what mechanical engineering is all about. It is a very broad canvas, and that is why it leads to various other opportunities. And what is more alluring of mechanical engineering, you can easily switch career roles. That is one of the fundamental aspect, because mechanical engineering provides a large broader canvas. And at the next moment, or the next thing which I like to highlight, mechanical engineering seamlessly overlaps with the other branches of engineering, which is difficult for any branch of engineering, let us say computer science, electronics or civil. So, mechanical engineering seamlessly overlaps with aerospace engineering, automobile engineering, materials engineering, the other aspects like welding engineering. These are all different, nowadays these are all institutions by themselves. And what is the beauty, that mechanical engineering can seamlessly overlap with all these areas. And what a mechanical engineer does, generally we perceive that a mechanical engineer has to think with a wrench in his hand. That is what I believe. He has to deal with big machines, oil spills, dirty hands and all that, and dirty apparels, but gone are those days. So, we need to get rid of these misconceptions. Okay, mechanical engineering has got a charm. You talk about anything, let us say you enjoy the luxury of a modern automobile, you enjoy or you savor the food items, the juices at your home, which is being transported from far around the continent and preserved. So, this is all about HVAC system that we talk about in mechanical engineering. Then every kid nowadays play with smartphones. Now, do you know, in mobile games, the dexterity with which you play the mobile games, it is the output of mechanical engineering. Or for example, now we are seeing robots involved in sanitation process, including the house, the industries or any campus. So, that is again a big contribution of the mechanical engineering.
Great.
So, it is a big charm.
Yes, my question was on differentiating mechanical with the others. You began with that, but you went deeper into what is mechanical engineering and what are the scopes of it. That is right. We will discuss them more in times to come, in the moments to come. So, you have got an overview of what mechanical engineering is and how is it different from other forms of engineering. Now, let us go deeper. Mechanical engineering itself encompasses various forms and classifications and types of engineering functions within itself. So, what are the specialized areas within mechanical engineering, and how do you differentiate one from the other? How do you define each of them? So, if you could speak on that.
See, basically, we segregate mechanical engineering to 3 specialized domains, that is we call design, thermal engineering and manufacturing engineering. Now, these are the 3 basic conventional or the foundation pillars, as we can say. So, in design, what we do, we try to ideate the product, we try to emphasize the technical aspects of the product, how it will evolve. So, it is all, earlier we used to have a blueprint, nowadays we do it in terms of computers. So, we use the digital technology to do that. Now, the other field is your thermal engineering. In thermal engineering, what we do, we try to deal with all the systems where a temperature or a heat source is involved. Okay, we call it thermal, and it deals with the systems like we are sitting in this air conditioned room. So, the temperature is being maintained, being monitored, is analyzed, and intelligent sensors can optimize the temperature level depending upon the number of persons sitting over here. the number of, the amount of carbon present over here. So it can be all monitored. So design engineering, then thermal engineering, which is specifically in the thermal systems, and comes manufacturing. And that is what we generally perceive as mechanical engineering is, because the lifestyle depends upon various products. Now, who is going to manufacture those products? Where it is going to be manufactured? How it is going to be manufactured? So all these questions are being answered in the domain that is called manufacturing engineering. Okay, now, but the design engineering has a bigger role to play, because it can, I would like to further emphasize, it is involved in the thermal engineering, it is involved again in the manufacturing engineering. So design engineering, what you can say, is the apex of the pyramid, and down flows the other things like thermal and manufacturing. But with the progress of time, with the advent of new technologies, the progress in the technologies, we have come across the other areas also, other than these basic three areas. So nowadays we talk about micro and nano systems, we talk about electric vehicles, we talk about energy management systems, we talk about materials and manufacturing systems, we talk about biomechatronics, we talk about artificial intelligence enabled applications, and we also talk about IoT enabled mechanical devices. So the span is, you can see, if you look at the pyramid, its base is expanding.
Right. You have spoken more from the machines and the utilities, but what are the titles? What are the special niche or specialized area titles under mechanical?
That's what, if we say that is the design engineering, thermal engineering, and manufacturing is
the broad three.
This is the broad three.
Right.
And under that, what we can say, the design engineering, we can say, let us say artificial intelligence enabled design. Okay. So we can
AI
say
design. Okay.
AI design. We can say design based on machine learning.
Okay. ML
right?
design. Okay.
Then CAD, computer aided design.
Right. AutoCAD. Right.
All those applications.
Computer aided design. So these are the under design.
Under design thing.
And
the thermal domain, if we go, we talk about HVAC, that is heating, ventilation and air conditioning systems. Then we talk about nowadays microfluidics, that's the emerging term, because we are talking about lab on the chip concept.
Right.
You can have every component which is monitoring your health condition on a small chip, that is what we call lab on the chip. So it's totally based on microfluidics, which is a branch of mechanical engineering. Then you have gas turbines and jet propulsion systems. So that gas turbine and jet propulsion engineering is also a part of thermal engineering, and it deals with what not. You talk about rocket science, you talk about missile technology, weapons, and the domestic airplanes and the fighter planes as such.
Very good. And the manufacturing engineering?
In the manufacturing, we have smart manufacturing, intelligent manufacturing, computer aided manufacturing.
Which are all together?
These are the subdivisions which can have under manufacturing, because see, there are very
smart manufacturing is computer aided as well.
See, actually there are very subtle differences between them, right? So if we talk about simply computer aided manufacturing, what we generally do, based on a design layout, we utilize a concept called your break before make.
Right.
Right. So we simulate that if we manufacture, what are the constraints, what are the difficulties that we are going to have. So that was the purview of the computer aided manufacturing. Now it is being taken one step ahead. So let us say, you are utilizing artificial intelligence to understand that if we change the parameters, right, so how the manufacturing process will be affected. Right. So that all those things you are doing before you are spending your time and money and the energy all together in the manufacturing. You sit just before your laptop, you carry out everything. So that's the world is moving towards.
So traditional mechanical engineering looked at the earlier traditional designing or the traditional thermal projects and all that. But today in 21st century, and particularly with 5.0, as you said, industry 5.0 coming, 4.0 running, what would you think will be the focus areas of mechanical engineering of tomorrow? Because students who are entering now, who are in first or second year, would be passing out 3 to 5 years from now.
Right.
So what would they be getting into? I understand technologies change in less than 5 years. How to teach mechanical engineering, will come to that later. But what would be the modern or rather futuristic focus areas of mechanical engineering? what you are also bringing in your department.
Right. So, now the futuristic focus whenever we talk about, then we need to talk about the current situation, the current industrial condition, the current economy and all that. So, when you look at the future, so what we are finding out that there will be tremendous shift to the digital technologies. So, those digital technologies are to be brought into the curriculum. It has to be integrated into the curriculum. Now, you cannot go for a curriculum which we have created in the during the Roman civilization, let us say, and you are trying to roll it out in the current scenario, let us say the COVID-19 post-crisis situation, right. So, digital technology will play a major role. Design engineering will encompass further domains, it will be much more enriched. So, that has to be also very beautifully integrated to the curriculum. Then what you are going to have is your interdisciplinary studies. So, students now has to focus or now has to come out of the boundaries or the constraints that I am a mechanical engineer, I have to be limited to the mechanical engineering domain. So, if you now look at the future aspects, nothing will be domain specific as such. There will be amalgamation, there will be overlap, there will be mutual collaboration between the different domains. So, that thing has to be taken into consideration, the interdisciplinary nature of study. Then venture ideation. So, that part has to come into picture, and slowly we are moving towards STEM plus A education. Earlier we used to have STEM education, now you are having STEM plus A education.
Science, technology, engineering, mathematics and arts, which also includes management and
right.
humanities and all
right.
that.
So, what we are bringing in, we are bringing in design thinking.
Design thinking, right.
Right. We are bringing in design thinking, we are bringing in venture ideation.
Right.
We are bringing in ethics, we are bringing in CSR.
So, you are bringing in management practices, entrepreneurship and
right.
social outreach
programs together also, that is in right. STEM plus A. Right. Then what we are going to inculcate, we are going to inculcate programming skills,
right.
because that is highly essential. So, in our curriculum we are developing a program called Beautiful Mind, and which is meant for programming for all, be a mechanical engineer, civil engineer, because as we see that programming is the future. So, you need to master that art also. Then apart from that, if we talk about the big tickets in the mechanical engineering that is going to affect the future. So, as I have already laid some of the points like micro and nanotechnology, the total the application will change, because earlier when you talk about mechanical engineering, we generally think of big things, we generally think of skyscrapers, we generally think of aeroplanes or high speed trains. But now the world is changing, smaller is beautiful. And as per Richard Feynman, the Nobel laureate, once he commented, there is plenty of room at the bottom, so explore it. So, that is what the world is moving towards, the technology is moving towards. So, in a nutshell, I like to put upon that in the future, the mechanical engineers has to go for design engineering as a major part, right. Then has to be ready with the interdisciplinary aspects. Right. Then has to look beyond the bigger things, has to concentrate on the smaller things in terms of micro and nanotechnology.
Right.
And they have to also go for artificial intelligence and IIoT, those applications.
So, BTech in mechanical engineering is there in 3,000 plus colleges and universities right. of India, and they are obviously, if they are giving a BTech degree officially, then they are all AICTE approved or they are UGC approved universities. How is your BTech in mechanical engineering different? How does it stand apart? Is there any USP of it in comparison to BTech mechanical of any other place or most other places?
Right. So, the BTech degree which we offer is right from the industry itself. Generally what we say that we generally follow that there is a gap between the academia and the industry. So, our motive was, why not include the industry itself right from the beginning of the formation of the curriculum, and so that we do not have any profound gaps which need to be depended upon later on. So, with that in mind, we focus on specializations like design engineering, we focused on minors like production management, we focused on minors, that is a mechanical engineer will have a minor in computer science applications, and that is going to do wonder. So, a mechanical engineer will be applying the knowledge of computer science, he can do a minor in that. Or let us say a mechanical engineer, so I am going to float a minor in the entertainment industry. We have a school of multimedia over here. So, mechanical engineers have a big role in the industry, entertainment industry. So, my students in the BTech curriculum, they can go for a BTech in mechanical engineering with a minor in entertainment industry even. Then we have other, as I said already, STEM plus A education that has been brought into our BTech curriculum with design thinking, interdisciplinary projects, avant-garde projects. Avant-garde projects, it's a beautiful concept in the sense that right from the, the day you join, you will be assigned with an interdisciplinary project. There are mainly 3 areas that we have figured out. Those are your electric vehicles, then airborne robots and smart cities. So, what the students will be do right from the day 1, they will choose one of such projects and they will get engaged, and as a result of which they have a taste of all the engineering disciplines. They understand how the collaboration between mechanical, civil, electrical, electronics, computer science takes place, and that collaboration technology or that collaborating skills will further propel the BTech graduate when he is ready for the industry. Then we have a beautiful mind program. These are certain USPs which I am trying to figure it out over here. So, where we mean programming for all. Then we have the concept of Tech Guru classes.
Right.
So, in Tech Guru classes what we do, we generally reach to the students with the latest technologies which is having a profound impact, because every curriculum has got a limited boundary, though we try to include more and more, but the technology is changing each day. So, the curriculum which you form at the beginning of the 4 years to continue. Now, how to get into the technology which is rapidly changing during these 4 years? So, we have a concept called Tech Guru. So, in Tech Guru classes, we offer such invoke technologies which is rapidly growing, which is rapidly changing. We bring it, we abreast the students with all those technologies. And after all, the most important thing which industry has been always pronouncing, that students lack communication and collaboration skills. So, communication does not mean only knowing English. It is a very wrong concept, I must say it very clearly over here. It is not only simply that you are very fluent in English, that is a part of course, but in technical field, communication means how do you present technical ideas. It may be artistic sketch, it may be a computer aided drawing, right. So, those communication skills are very important. Then collaboration. It is generally said that on the field or on the shop floor, the EQ matters more than the IQ. The emotional quotient, the emotional intelligence of the person is the one which leads you to success in an industry. You have to collaborate, because basically a graduate engineer is employed as a technical manager. He has to manage a big workforce under him or her. So, what he has to do? He has to collaborate with the workforce under him, and for that he need to have that emotional intelligence. So, what I can say, it is a big basket of offering, and the students are requested to be quite aware of the program what they are joining, try to find out what is the content of the curriculum, and then only decide your path.
Great. That really goes deeper into the USPs of the BTech education that you are offering at your school. And the best part is that there are modern technical elements which have come in the domain of mechanical engineering. Also, you have added the CSR and the humanities and communications angles as well very effectively. Now, how does MTech in mechanical engineering appear there? How different is it? Are you further specializing within MTech or going deeper into 1 or 2 domains only? And why should someone do an MTech and not just become an engineer after BTech? So, what is the value addition that MTech brings in? What the specialization areas that the MTech brings in, if you could speak on that?
Right. So, MTech is a post graduation course that is called Master of Technology. And see what happens, as I said in the very beginning, that the learning has to be student centric. So, when you talk about student centric learning, now different students have got different interests, different passions they pursue. Now, some may go for a BTech and then join a company, or can set up his own entrepreneur initiatives, okay. And some may continue in the domain of research. Because what is the beauty is that a engineering discipline, particularly let us say a mechanical engineering discipline, opens up a scope of infinite possibilities. So, who will not be enthralled if he or she finds that later on in the future it is his or her ideated technology that is being commercialized. It is a big satisfaction, a big passion. So, those students who are having a passion towards research, or they can go to academics, they generally pursue your MTech degree, master's degree. But moreover, one thing has to be kept in mind. Now, the Indian industry sector has investing largely on the R&D sector, that is the research and development. So, that sector is on the scouting of skilled MTech students. So, the MTech students also qualify for that. Now, how MTech is different from BTech? Now, in BTech, as I talked about, we generally go into a overall picture. What is mechanical engineering? What are the basic things? What are the further domain specializations and all that. In MTech, what we are supposed to do, or what we do as per our curriculum, that within that domain specialization, because there are many branches flowing out, it is like tributaries of a particular domain, let us say design engineering also. There are many other branches. You talk about micro electromechanical systems, you talk about advanced mechanical engineering design, you talk about ergonomics design, you talk about HVAC design, you talk about firefighting equipment design. You see the basic domain was design engineering,
yes,
which was covered in the BTech curriculum. What is an overview? Now, you go flow along the tributaries of the design engineering.
Application in a particular
domain. Particular domains, right. Domain, yes. So, we are floating MTech in design engineering.
Very clear.
With those particular.
So, what are the different MTech courses? Design engineering and?
Design engineering, and currently what we are going for design engineering only, because what we feel that is the call of the future.
Right, great. So, that is MTech design engineering for you. Much focused, research oriented and application oriented in a particular domain. If you have to look at overall the domain of engineering education, there has been a decline in engineering learning in recent times, particularly in traditional engineering learning, in which mechanical is one. How are you combating this trend, and are you seeing whatever measures you are suggesting, are you seeing a turnaround in that? So, if you could specifically talk on those areas.
In fact, I am very confident about the turnaround, because what we have been lacking and what causes a decline in the engineering is because the earlier the academics was ruled, or I will say the academics was framed mostly by the academicians, and they were sort of aloof from what are the industry requirements. Now, ultimately, when I know that my product is going to be absorbed in an industry, how can I be indifferent to the industry aspects? For example, industry wants that go for technical skills, not just from the product point of view, but go for the system point of view. So, system engineering has to be involved.
Right.
We do projects, but we do not understand what is the project management skill. That is what an industry requires, because industry has a target to meet. All the projects are target oriented. So, project management skills are a must. Now, all these factors were not looked into or not brought into the curriculum, which caused a decline in the engineering demand, because ultimately the products which were churned out by so many private engineering or government aided institutions were not absorbed. So, we have been promoting that industry is in the need of manpower, but we are not able to place our own students. So, what is the problem? Where lies the lacuna? The lacuna is what we are churning out are not appropriately skilled to be absorbed by the industries. So, what we need to look upon is to develop the right skill sets which the industry will approach the academia that give me those graduates which are having the right skill sets. So, that decline in the engineering is sure to have a turnaround if we consider these aspects. So, develop the right skill sets, have an interdisciplinary set of mind and choose the right curriculum which is going to bring you forth into this specialization.
So that's redefining mechanical engineering in times of Industry 4.0 moving to 5.0 and redefining in the context of managerial skills and social outreach as well. That would bring in more attraction towards engineering education. Could you also speak about your graduates going into the job market in the last 2 years particularly? And I understand that many of these changes will be reflective in the future. But as far as the last 1 to 2 years is concerned, what has been the performance? Which are the sectors which have been employing youngsters more?
Right. So, we have just one batch graduated and another batch is about to graduate, and in fact, because of this COVID-19 situation, there is a bit delay. But I am happy to note that the majority of our students have been absorbed and have been absorbed in the sectors which they wanted to be in. So, more importantly, what we try to understand in the manufacturing sectors, in the automobile sectors, there is a big demand, and we have been training our students in that particular mode, so that there is a they can meet the demand or the expectations of the industry. And more importantly, what I like to say that software engineering is also not aloof from the mechanical engineering domain. So, few of the students have also placed in software engineering, because I like to point out very clearly over here, generally we have an idea that software engineering does not cater to the mechanical engineering domain. But let me tell you, now this Internet of Things or the IIoT is churning out huge amount of data, it is presently also doing so. Now, who is going to analyze that data, who is going to manage that data, who is going to clearly apply that data into the future actions?
Right.
The one who understands the data.
Right.
Now, this data is originating from, let us say, the various manufacturing plants, the industrial machinery, and because IoT is nothing but connecting the computers with the physical world with the help of sensors,
right,
and the digital devices. Now, this data has to be interpreted, and this data can be interpreted only by an engineer who has idea about manufacturing or the machinery.
right.
So, there lies the role of the mechanical engineer and its aptness for the area of software engineering. So, the performance has been quite all around. We have in automobile sector students being absorbed, we have in manufacturing sector as well as in software engineering sector.
Right, great. How has the COVID pandemic impacted the world of mechanical engineering? What have been the visible and not so visible impact, and what are you looking forward to in the new normal?
Right. So, the COVID-19 has really posed unprecedented challenges in terms of shortage of supply chain. There has been plans for postponing or even cancelling capital investment, and there has been also lean production. The production has gone lean, or what I can say that this unprecedented challenges has affected the industry and the mechanical engineering sector as well. It is now the question is, what have we learned anything because of these challenges that we have faced? Now, that is the beautiful side of the this pandemic situation. I should say the advantageous side, it taught us many lessons. It taught us lessons that we are not well equipped to deal with this medical urgency. We need to manufacture more and more medical and personal health equipments. So, we understood that we need to monitor remotely the manufacturers, the manufacturing machines. We need to monitor the workers and the operators. So, these are these learnings which has catapulted into the certain steps which industry, including the in the mechanical domain, what they have thought of. Like they are going to ramp up production in certain sectors and ramp down in certain sectors. They are going to shift the production. For example, in this COVID-19 situation, In fact, if I remember, we have seen automobile industries manufacturing ventilators or face masks. So there has been a shift in the production. So with these things keeping in mind, now the post-COVID situation, the positioning and the growth will depend upon application of digital technology in a big way. Application of artificial intelligence, application of Internet of Things. Now all these things will percolate into the mechanical engineering domain also. So when we get the students ready for the future, we have to have such a training, such a counseling, such a mentoring, such a curriculum which takes into account the futuristic industry concepts into the present curriculum that the students will be imbibing.
Great. That was an overview of how industrial revolution and manufacturing engineering evolved throughout the ages, from industry 1.0 to the current 4.0, and how it can and what it shall be in industry 5.0. That was also an understanding of natural sciences, engineering and technology, various domains of engineering and various specializations within mechanical engineering, particularly focusing on design engineering, thermal engineering, manufacturing engineering. I am really personally also enriched in understanding niche areas within design, within thermal and within manufacturing as well. That's something every wannabe mechanical engineer must know before entering into this field. We have also covered how engineering education traditionally has prepared technocrats, but they were not strong on management practices, for example, on project management, and how they needed also to be connected to communication skills and societal outreach. That's where a complete engineering professional evolves. That's how. And hence, Professor Saikat Chatterjee, Head of the Department of Mechanical Engineering, School of Engineering and Technology, Adamas University, Kolkata, elucidates upon the various futuristic trends and inclusions in their syllabus, in their coursework, in their programs of these new trends. He has also told how an MTech is different from BTech, and particularly the MTech in design engineering which they have evolved. And finally, he has drawn upon the current impacts that the COVID-19 pandemic is having on the field of mechanical engineering, and how digital learning and practice of mechanical engineering would be evolving in times to come furthermore. He has also given a regional expansion, not just a historical expansion of industrial revolution and mechanical engineering. So young ladies and gentlemen who want to be the harbingers of industrial revolution and mechanical engineering in times to come, here is your world, and here is your guru, and here is your department. Over to you now to take a decision and evolve in this particular field. Exciting, interesting, evolving world of industrial revolution and mechanical engineering in times to come. With that, we bring this session to an end. Thank you, Professor Chatterjee, for your time and very erudite talk throughout the last 1 hour.
Thank you
very much.
You.
Hey, welcome to Adamas.
My research is on my way. I am very much proud to be a part of Adamas University.
Cricket is my passion and I am proud to be a part of Adamas University.
You have misused, I believe.
Hi, I'm Deboshmita Biswas.
This is Kunal Kanti Maiti.
I'm Srijo Nicole. This college has given me placement in one of the best companies in US staffing, which is Iconma. I am proud to be a part of Adamas University.
Pursue excellence. Adamas University.
Biosciences and technological developments based on biology, including entrepreneurship in this sector, are on the rise in India. We are home to many developments in all forms of biotechnological products with applications in food, nutrition, healthcare, packaging, etc. The unique BTech and BSc programs in Adamas School of Biosciences and Biotechnology are path-breaking academic innovation in this sector. Welcome to the world of biotechnology. As India aims for $5 trillion economy, the nation needs a large pool of trained economists and commerce graduates, focusing on taxation, macro and microeconomics, etc. Adamas School of Economics and Commerce is in the mission preparing finance and economics professional to lead this journey with value-added modules on the stock market and big data. Education today is changing the traditional chalk and talk method into new age experiential learning. New techniques like flipped classroom, case study method, and increasingly higher component of learning by doing are changing the game. Also, evaluation processes are evolving from just semester end exam to continuous evaluation. Jury judge practical work, life projects, and whatnot. Adamas School of Education prepares these new age teachers for schools and colleges of India. It is important to be on the right side of the law and even more important to ensure justice for all. The Adamas School of Law and Justice firmly believes in this dictum. With moot courts, national and international seminars, debates and initiatives of various type, the law school offers integrated courses with BBA, BCom and BA as well, with different focus areas. A top-class hands-on engineering and technology education with high emphasis on soft skills, emotional intelligence, artificial intelligence learning. The Adamas School of Engineering and Technology is a trailblazing institute. It integrates learning in the classroom with the laboratory, workshops, and the factories or the corporate offices. It is also associated with several universities in the world. With a 24-hour work culture, Adamas School of Management prepares professionals for marketing, human resources, finance, supply chain management, and pharmaceutical management for the new Indian economy targeting $5 trillion annually. Close association with several top corporate houses and intellectual talent in the classroom, the school is proud to have one of the highest placement records in East and the Northeast India. With a 2% share of the India's GDP, the media industry is growing faster than India's GDP. And with the world's largest number of films and television channels, it is the national informer and entertainer. With more than 1,000 films a year, cinema is our soft power. News, entertainment, brand communication, we lead Asia in all. And a multi-skilled multimedia talent is being trained in the Adamas School of Media and Communication.
Want a good job in a big city after college? Then don't skip this ad. For a great professional future, you need college education with hands-on training, smartness, and a network of talented friends. And you'll get it all at Adamas University. Professors at Adamas share their expert knowledge with students and also equip them with industry skills. Register now for Adamas University admission test and take the leap into a bright future.